Hello everyone. So today let's solve the problem 139 word break, right? So what the question states here, we have been given a string s. See here, we are given a string s, right? Uh, and here this characters LEETCOD, lead code basically, right? So we have been given a string s and the dictionary of strings word dict. So we have been given the dictionary of the strings basically. Lead, we have code, word lead, word code. This comes under this one, word dict string, right? So we have to return true if s can be segmented into the space separated sequence of one or more dictionary words, right? So we have to return true if s can be, so this can be segmented into a space separated sequence of one or more dictionary words, right? So here this can be, see here, lead and code. We have to return true because lead code can be segmented as lead as well as the code, right? So we have this one is present in the S basically. This is possible. We have to return true. We have apple, pen, this one apple, pen, and apple, right? So apple, pen, apple we have. So in the word dict, we have only apple and pen. So this is possible, right? So we have this one, apple, pen. The words are present in the input as apple and pen. This can be segmented, right? So in that case, we have to return true. Next, we have cats and dog. In the word dict, we have cats, dog, sand, and cat basically, right? So here this is not possible. This is not possible. In that case, we have to return. If it is not possible or if it is impossible, then we have to return false, right? So this is fine, I believe. They have given us wonderful examples just for the sake of understanding. Now let's do one thing. Uh, let's quickly discuss the, approach followed by the complexities, and then let's write the code, right? So here, what's the question again? Given a string s and the dictionary of strings word dict, return true if s can be segmented into the space separated sequence of one or more dictionary words. Note that same word in the dictionary may be reused multiple times in the segmentation, right? So just give me a second here. Yeah. Now, before hopping into the approach part, let me tell you one thing. So we will be going with a dynamic programming to solve this particular problem, right? So we'll be going with 1DDP. So we'll be going with 1DDP to solve this particular problem. Now let's discuss the approach step by step. So let's consider the first example, same example. Right, so this is fine, man. First approach here would be S equals lead code. So let me go with here S equals lead code. This is fine. S equals lead code. Yeah, this is fine. We have considered word dict. We have lead and code. This one will be considering. First, what we will do, we will create the DP array DP of I. First step is we will create the DP array DP of I, where DP of I initially will set this one to the Boolean value true, right? So this means the substring from S of 0, initial one, S of 0 to the last one, I minus 1, can be segmented using the dictionary. Initially, we'll set this one to the true. Just remember this one, right? So the second one here, second step, we will initialize DP of 0 to true. What we will do, we will initialize DP of 0 to true, right? So this is empty string is always segmentable, right? So just remember this. Next, let's move on with the third step, man. Let's move on with the third step. Third step here, we have to, or we will be iterating I from 1 to s dot length. So we'll be basically iterating I from this one. Basically, we'll be starting with the 1 actually, as we have initialized the DP of 0 to true. So we'll be iterating I from 1 to this one, 1 to length of the S, basically length of the string. So each letter in the S will be iterating through, right? So this is fine. Yeah, easy. So now for each I, we will check all the words in the word dictionary, right? For each I, so we are going through the individual letters in the S here. L, E, E, T, C, O, D. For each I, for each letter, first it will be, we'll check for the whether this is present in the word dict. L is present. Next we'll check for L, E. L, E is present. Next we'll check for L, E. L, E is present. Next we'll check for leet. Leet is present, right? So this is how we will check. If the words end at the position I and the substring before it is segmentable, nothing but dp of I minus word dot length that is equivalent to the true, then we will mark dpi as true. Simple one. If it is possible, then we will be marking this one as true actually. dp of I equals to true, right? For the lead code, for the example, see here. So first lead ends at the index 4. So see here, 0, 1. So we'll be starting with 1, right? As I've said in the approach. 1, 2, 3, 4, right? 1, 2, 3, 4. So this stops at the 4, right? So this ends at the index 4. So dp of 0, what we will do for the example, we will set dp of 0 to true, right? So dp of 0 to true. So we are iterating from 1 to 4. We are considering this one as one based index, right? So this one lead, so this one lead ends at the index 4, index 4. So this one is present in the S basically, right? So in this case, we will be going with dp of 0 equals to true. This is fine, I believe. Next, again, we'll start from the C here. We'll start from the C. And C, we will check whether this is present in the this one word dictionary. O, we will check. D, we will check. And E, we will check. And yeah, the code is present in the basically this one input, right? Input string, yes, right? So this one again, what we will do, this ends at the index 8. This one ends at index 4 and E, this one, the last index is 8 here as we are starting with 1. So again, what we'll do this time we have started from the index 4, right? So we have started from the index 4. So we will set index 4 to true as well. We will set index 4 to true as well. So what we will do, we will mark dp of 8 equals true, right? So dp of 4 was the first, this one last index for the first word lead, and 8 is the this one, the last word for the code, actually it is ending at 8, right? So what we will do, we have marked dp of 4 equals true, and also we have marked dp of 8 equals to true. We have found the two words in the word dictionary in the input string is successfully, right? So that's what we have done. In this case, we have marked both as true, right? Finally, dp of s, this one length of the s equals dp of 8, right? So we have went through all the words in the s. Finally, the length of the s, dp of length of the s is equivalent to the dp of 8, right? So which is basically true, which is basically true. So the output that we got here is true, right? So this one we will return. Length of this is equivalent to the dp of 8, which is dp of 8 is true, right? So dp of 8 is true. So the output that we got here is true. We will return true as output, right? So which is equivalent to the output that they have mentioned for the example 1 within the question, right? So our approach works absolutely correct in this case. As we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity here? The time complexity would lead to big O of n into m into k. So why it is big of n into m into k here? Because n is equivalent to the s dot length, length of the string s, this one, length of the string s, and m is nothing but the size of the word dictionary, so this one, right? So here in this case it is size is 2, latent code we have, right? K is nothing but the maximum length of the words, right? Just for the substring comparison. So overall we can write here this one, the time complexity would lead to big of n into m into k. So what would be the space complexity here? Space complexity would lead to big O of n plus m, right? So why it is n plus m here? So n for the dp array, right? M for the hash set storage of the dictionary, right? So overall, we can just consider here this one space complexity. We can just consider this one as big of n plus m. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n into m into k and big of n plus m respectively. Now, as we are completely familiar with the approach as well as the complexities, we are good to write the code. Let's start writing the code, right? So first one, let's convert the word dictionary to the hash set just for the big of one lookup. This is faster, right? So I'll just go with the set here, which consists of a string, right? So which is of the type string basically. Just go with a variable dict here, which is relevant to this uh, problem. I'll just go with a hash set. Hash set, we have to go with a capital S, I believe, right? The Java. Yeah. Now let me complete the syntax. So we have to pass word dictionary here, right? Let me pass the same. This is fine. Yep. Now let's do one thing. Let's initialize the DP array and set the DP of 0 to true basically as per the approach, right? So this one, let me go with a DP array. As I said, we'll be going with a DP, right, to solve this particular problem. So this one will be new boolean of length of the S. We know this, and along with a 1 for the safety side. Also, let's set the DP of 0 to DP of 0 to true. So we are just going with an empty string that is segmentable, right? So now let's do one thing. Let's iterate through all the positions of S. Let's go with a for loop here. This one in I equals 1 I less than or equal to length of the s. This is fine. I less plus. So this is fine. So within the for loop, what shall we do? Let's check every word in the dictionary, man. So this one will be for. Mm, so let me go with here. String word of within the dict, right? We are considering the variable name dict initially. I've considered variable name dict. So this is fine. So within the for loop, let me assign length to length of the word basically, right? So I'll just go with let me type this one word dot length. So this is fine now. The next step would be if the word fits ending at the I and the previous part is segmentable, then for that one we have to write the if condition, and if it is segmentable, then we have to mark the current position as segmentable. Nothing but we have to set dp of I to true, and we need to uh, check other words, meaning we have to break from there, right? So let's write the simple if condition first. If I is greater than or equal to length and dp of I minus length here minus length and this one s dot substring here, this is fine. This is equivalent to I minus length comma I, this is fine. Dot equals of word, so this is also fine. Let me set dp of I to true, this is also fine. The next step would be we need to check for other words as well, right? So this is fine. Break. So let me come out of this one entirely now. uh, Format so that this looks good actually. This is fine. Let's continue from here, man. Yeah. So here what shall I give? So all we have to do here is we have to go with the we have to return dp of s dot length here, because this tells if whole string is segmentable or not, right? So I'll just go with as per the approach that we discussed, right? So dp of s dot length, right? So this is fine, man. Yeah. Now, yep, this is it actually for the code. Let me format the code once and let me hit the run button. I hope this works. Let's see. This is actually the simplest code, man. Yeah, this is fine. Uh, thank God this works actually. Yep, let me hit the submit button. Let's see whether this works for all the test cases or not. Yeah, this works for all the test cases, right? I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.